Hi there everybody, this is the recorded class of the class that you would have had tonight, T7C1. So this is pre-recorded live speech marks. Okay, now we're starting on chapter 12, we're looking at matrices and their determinants. And before we do that, we just need to think a little bit about ordinary numbers and inverses. And for example, 3 times a third is 1. And there we're talking about multiplicative inverses. And if we were talking about 3 plus negative 3 equals 0, that would be the additive inverse. The inverse when you are adding. There's some rules about transposes. All of these things are on my math lab, but transpose is where you swap the rows for the columns, and there are rules, but every matrix is written or described as row by column. So a 3 by 3 means 1, 2, 3, 1, 2, 3, 1, 2, 3. And it's 3 rows by 3 columns. And everything to do with matrices is row by columns. If we're talking about a 3 by 2 matrix, that means we've got 3 rows and 2 columns. So this is important when we want to multiply. If we're going to multiply, we can only multiply if the number of columns of A is equal to the number of columns of B. So if we have a 3 by 4 matrix, we can only multiply it by a matrix that is 4 by 2, and then the answer is 3 by 2. So this is the shape or the size of the matrix. Now, we need to be able to identify a particular element. So if we talk about C32, what it means is it's the element in row 3 and column 2, and in general terms it's the ith element of the jth row. So if we were talking about Cij, that's what we'd mean. Now we need to start talking about the determinant, because the determinant is what we need to be able to find when we're finding the inverse. It's written like that. It doesn't mean absolute value. And for a 2 by 2, it's easy to find. It's simply AD minus BC, like that. It's a lot more complicated when we have a bigger one, but when we get to do it, you'll see that it's just each term times its cofactor and added along. There are rules for determinants which you will need to learn. I can't remember how many are in the formula sheet, but you just need to learn those rules, just like learning tables really. And more rules. We can think of a matrix, say this one, and if we wanted to divide it by 5, then each element would be divided by 5. Like that. And property 5, if 2 rows or 2 columns of the matrix are equal, then the determinant is 0. That's something you need to particularly remember. Now, just remember, 3 times the inverse of 3 is equal to 1, because 3 times a third equals 1. Now, we talk about this as being the identity in multiplication, and it's the same here, but if we're going to use it in matrix terms, then we'd have almost 3D, if you like. But it can also be just 2, or it could be 4. We make it as big as we need to do. Now, if we're trying to find the inverse, as we need to do from time to time, then we have to go through and find the determinant. In this case, we cannot have the inverse equal to 0, because you can't divide by 0. So if the determinant is 0, then we can't find the inverse. So for 2 by 2, you swap that diagonal around and swap that diagonal around, multiply by 1 over the inverse, 1 over the determinant, and make this diagonal negative. So you can learn these. You can learn them. Doesn't hurt to learn them. The reason that we need to find the inverse is because we can't actually do division, and we need to be able to find the inverse instead of finding the division. Remember, the parallel lines, it's the determinant, and these little things we pronounce A, D, J, as we call that the adjoint. If we were going to solve something like 3x plus 4y plus 5z equals 2, what we would do, well, we'd have a whole series of them, and we would start entering it into matrix form, 3, 4, 5, and all the other ones that we needed to solve simultaneously. Now, I haven't written out the other equations, but if we wanted to find x, y, and z, then we need to find the inverse and multiply it by, if this is A, B, C, because we'd really need, in ordinary algebra, we'd need to be dividing it. We can't divide using matrices, so we have to multiply by the inverse, which is the same thing. Here's an example here. So we need to find the determinant first of all, and then we need to find the little bits. So we'll start off by finding the determinant of h. Now you can do it the official way, so it would be 4 times the determinant of the little bit that's left, which would be 6, 0, negative 4, 5, and then minus, then the next one is negative 2 times the determinant of what's left, which would be 9, 0, 3, 5, and then the next one will be plus, so it's same, change, same, and the next one is 1 times what's the determinant of what's left, which would be 9, 6, 3, negative 4, and we work all those out, so it would be 4 times 30 plus minus minus plus 90 minus 54, which gives us 156. Or you can do it a tricky way, which you may like to do, for a 3 by 3. So we've got 4, negative 2, 1, 9, 6, 0, 3, negative 4. That noise you can hear is my dog trying to dig a hole in the couch. Like that. And then we just repeat the first column and the second column like that. Now what I'm going to do is I am going to use a red pen and I'm going to multiply along the diagonals. So I'm going to multiply along there and that gives me 120. I'm going to multiply along there and it gives me 0. And I'm going to multiply along there and it gives me negative 36. Then I'm going to go the other way. Let's change colors. Let's go to green. Then I'm going to go this one, multiplying along there, and I get 18. Multiplying along the second one there, and adding them all up, I'm going to get 0. And then on the last one there, I'm going to get negative 90. So negative 2 times 9 times 5 will give us negative 90. Now the way to put it all together is that we're going to put the first bit in brackets, so at 120 plus 0 minus 36 minus, and then do the green bit, do the green bits, which would be 18 plus or minus 0, doesn't really matter, but it will be plus 0 minus 90, which will give us 156. So whatever way you want to do it, that's fine. Now we need to find the little bits. We need to find the transpose, because the inverse is equal to the adjoints of H over the determinant, which we know as 156, because we've already worked that out. Now we need to find the transpose, because that's part of it. So we need to swap the rows for the columns. This may well run into a second video, so I'll just start from where I finish. So we've done that. Now we need to find the little fellas. So A11 would be the determinant of 6, negative 4, 0, 5. A12 will be the determinant. So what you do is for A11, kind of put your finger over the row and the column that A11 are in and find the determinant of what's left. All of this is explained in greater detail in the main video. Find the determinant of that, which would be negative, because it needs the cofactor to be swapping from positive to negative. And then A13 equals the determinant of negative 2, 6, 1, 0, which is 0 minus 6. Negative 6. And then A21 equals 9305, which is negative 45. I'm going to run out of room. And time 2 equals 4315. A23, I'm trying to keep an eye on the time as well, equals the determinant of 4910, which is 9. Then see if I can scramble A31. I'm just going to write it down. A32 equals negative 10, and A33 equals 42. Right, I'm going to stop the video there, and I'm going to carry on for the next one.